Namaskar, I am Dr. Nisha Rani, Superintending Geologist from Photogeology and Remote Sensing Division, Geological Survey of India Training Institute. My session is on application of remote sensing. Remote sensing data have shown tremendous potential for application in various fields including geology, agriculture, forestry, mineral exploration, geo-environmental studies, weather monitoring, disaster management, etc. During my session, I will be discussing on geological application as well as application of remote sensing in different fields. Geological applications of remote sensing include the following: lithological mapping, mineral exploration, structural mapping, superficial deposit or bedrock mapping, geohazard mapping and planetary mapping can be done with the help of remote sensing, sand and gravel exploitation, environmental geology, hydrocarbon exploration, geobotany, sedimentation mapping and monitoring, event mapping and monitoring can be done with the help of remote sensing data. In mineral exploration, remote sensing data is very useful for lithological mapping, alteration zone mapping, structural mapping, geomorphological mapping and geobotanical studies. Lithological mapping. The lithologically bound epigenetic or syngenetic deposits are formed due to the strong preferences of host rocks. Here one example I have shown. You can see here different lithologies you can identify from the satellite imageries, and if any lithology is hosting any mineralization, then you can trace the extension of that lithology. That can be useful for your mineral exploration. Structural mapping plays an important role in mineral exploration, hydrocarbon exploration, potential hazard identification and monitoring. Here you can see in this imagery, you can identify the folds. You can demarcate several lineaments from satellite imageries and fractures, faults, which can play an important role for mineral exploration. Alteration zone mapping can lead to potential area for mineral exploration. Hydrothermal alterations are commonly indicated by iron oxide, hydroxyl bearing minerals, carbonates and sulfates, and identification of these minerals can be done through the remote sensing. Here one example I am giving you. These different colors are actually alteration zones which are present in the area, and this can be achieved by the remote sensing data. And here we can see the spectral signature of different alteration minerals which have different absorption at different wavelength region. On that basis we can identify different alteration minerals also. Through remote sensing, geomorphological mapping can be done. For example, for placer deposits, buried channels, abundant channels, meander scars are very important. With the remote sensing data sets, these buried channels, abundant channels, meander scars can be marked, which can be proved potential zone for the placer deposits. Deposits formed by the process of residual and supergene enrichment can be indicated by geomorphological features like hills, ridges, plateau and valleys. Those can be marked through the help of remote sensing data. Remote sensing data are very useful for the identification of geobotanical guides. For example, reflectance spectra of foliage growing over mineralized areas may differ from the spectra of foliage in adjacent non-mineralized area. Here we can see some example of same foliage which are showing different spectral curve. Remote sensing data can be used for the coal fire environment studies. Surface temperature measurement can be done with the help of remote sensing data. Here you can see the example of Jharia coalfield. Air pollution you can identify with the help of remote sensing, and you can measure the surface temperature. You can see this red and yellow color. Red is ranges from 45 to 56 degrees C and yellow from 39 to 45 degrees C. Landslides are directly affecting the ground surface, so the application of remote sensing techniques are very suited to slope instability studies. Monitoring of landslides can be done both in accessible and inaccessible areas with the help of remote sensing data. Ground deformation and tectonic studies can be done with the help of remote sensing data. Monitoring of volcanoes can be done with the help of remote sensing data. Here we can see volcanic eruption happened and lava is flowing in this direction and this direction. And here we can see volcanic eruption happened, and these are the volcanic ashes with the smoke that can be monitored with the help of remote sensing data. Remote sensing data can be utilized for the preparation of drainage map, identification of different drainage patterns, and we can also identify the different orders of streams. Remote sensing data is very useful for the basin analysis, identification of watersheds and catchment area. Slope map can be prepared with the help of remote sensing data. This map can reveal structural lineaments, fault scarps, fluvial terrace scarp, etc. Remote sensing data can be utilized for the aspect map preparation. It identifies the downslope direction and calculates how many slope directions are present in the study area. Aspect images may enhance landforms such as fluvial networks, alluvial fans, facet, fault-related scarp. With the help of remote sensing data, hillshade or shaded relief topographic map can be prepared. It helps in identification of fault, fracture, lineament. Here we can see one fault is there. Like this you can identify there are fractures, or we can say lineaments are here. We can demarcate with the help of hillshade and shaded topographic relief map. Contour map can be also generated with the help of remote sensing data. With the help of remote sensing data, we can prepare 3D surface. Here we can see hilly areas, moderately sloping areas, gently or planar areas we can see here. So with the help of 3D surface, we can visualize our area. Other than geological application, remote sensing is having a vast application in different fields also. Remote sensing is very useful for the groundwater potential zone mapping. With the help of remote sensing data, lineaments, dikes, valley fills, paleo channels, abundant and buried channels can be identified. Flood plains, alluvial fans can be marked. Interdunal depression, anomalous vegetation patterns can be identified. Surface water bodies and springs can be demarcated with the help of remote sensing data. Remote sensing can be used in the civil engineering also, for urban and regional planning, site investigation, terrain mapping analysis, water resources engineering, town planning and urban infrastructure development, transportation network analysis, and landslide analysis. Remote sensing can be used for land use and land cover mapping. It helps in monitoring dynamic changes, urban and rural infrastructure, water logging and salinity, infrastructure monitoring, availability of usable land, assessment of spatial distribution of the land resources, future planning for better and land management for socio-economic development. Remote sensing data is useful for the surface temperature monitoring. It is also useful for the detecting and monitoring of wildland fires. Change detection studies can be done with the help of remote sensing data. We can see here. Remote sensing data is useful for the monitoring of flood damage to standing crops. Remote sensing is very useful for the agriculture. It helps in crop acreage estimation, crop modeling for yield and production forecast or estimation, and crop monitoring. Remote sensing is very useful for the forestry. Satellite image based forest resource mapping and updation can be done. Forest change detection can be done. Deforestation can be monitored. Damage from pollution and pests can be monitored. Suitability and productivity assessment can be done. Forest resource inventory can be prepared. Fire management can be done with the help of remote sensing data, and GIS database development can be prepared. Remote sensing is very useful for the infrastructure development. Vehicle movement monitoring can be done with the help of remote sensing data. Here one example is given. We can see this pre-lockdown period. On the roads we can see several vehicles, and after lockdown we can see these roads are without vehicles. Remote sensing is widely used in weather monitoring, for example for cyclone monitoring, for flood monitoring, for heat waves monitoring. Remote sensing data is being used. Utility of remote sensing in defense and military. Remote sensing data are very useful for coastal area surveillance, ship detection in coastal regions, landmine detection. Human activity monitoring can be done with the help of remote sensing data. Thank you. This is the end of the current session as well as end of the course on basics of remote sensing. Once again, thank you for attending the course.